Okay, now I'm mic'd 2 times. Sorry about that, everybody. You're all busy people, so you want to at least kind of know what we're going to cover for this presentation. Because the title can be somewhat vague. When people hear the term climate change, their mind goes 100 different directions on what that can mean. In our case, we focus primarily on the natural factors of climate and determine and see how those factors influence people, societies, economies, business, investments, and a whole range of different industries and social norms. And the first thing, the most important thing to keep in mind is that climate ebbs and flows. It's ever changing. We don't use a model that we plant in figures when we do our research because it changes too drastically. So currently, we're in an El Nino. The El Nino was officially declared by the NOAA in March of this year. And along with our research, there's a pretty much agreed upon norm that there's a 90% chance that this El Nino will continue on into winter and go through the entirety of winter, and that it should go into spring, 85% chance of it lasting through spring. Now, in addition to this, it's been a very strong El Nino, and it's going to be a strong El Nino through winter time. But normally, after a strong El Nino, within a short amount of time, sometimes as few as 2 to 3 months, we get a La Nina. So I'll explain more about that and what that means for the future of agriculture in the U.S. Now, additional to the El Nino, something that you don't hear about nearly as often when it comes to climate data and research is volcanic eruptions. And we had in 2014, August of 2014, the eruption of an Icelandic volcano called Bardarbunga, which is a fun name to say, so I'm going to probably say it 3 or 4 more times throughout this presentation. Bardarbunga erupted and released a vast amount of gas and aerosols into the atmosphere. And even though it happened in Iceland, and even though it happened almost 2 years ago, at least a year and a half ago, it's still affecting the weather that we are experiencing today. Now, the combination of the El Nino, the oceanic cycles that we're looking at, the volcanic eruption of Bardarbunga, so you said it again, and the jet stream patterns that we're seeing makes for a relatively dry and warm winter in the north and northeast, in parts of the northern U.S. and southern Canada. Now, for those of you who've been seeing the snow flying around and hearing about what's happening in Illinois, you might question that statement. But the Northeast is going to have a double dip winter, and what we get in these sort of current conditions is you get extremes. You might find that over the course of a month, an area got 15 inches of snow. Not too bad if that's a couple inches every couple days, or every few days, or 3 inches a week. No, what often happens is they get 13 inches on a Monday. And then Tuesday they get the other 3 inches, and that's their snow for the month. And that's one of the things that we're seeing. It also brings wet, stormy conditions into the south, and wetter and stormier conditions in California. It also means that the eastern corn belt has a good chance of having dry soil conditions for springtime planting. Finally, as was said, I'm an international business. I was an international business major. I have my degree in it now. And so I do a global perspective. Europe and Asia, because of this El Nino, and to a degree some of the eruption from Bardarbunga, has had a very rough growing season and harvesting season this year. And their yields were lower than expected. Offsetting that was the United States, which had higher than average yields for their various crops. So now we're keeping an eye on South America. Near the end of the presentation, I'll talk a little bit about South America. I call South America this year the tiebreaker, because it's going to determine whether the global yields of a variety of crops and commodities is higher or lower. Now, just a little bit of background about what we do in Browning Media. When it comes down to it, we follow energy. We follow the energy from the sun. We see how strong the energy from the sun is. Are there solar flares affecting it? Is it a shadow time? And we then see where the energy from the sun goes. And what's going to block it? Is it clouds? Is it volcanic activity? As much as I love my job, everybody, I do realize I'm in the wrong line of business. Several years ago, the government conducted a multi-million-dollar research grant. Scientists got rich off this. And they determined that if you are underneath a cloud, it's cooler. So we watch where that energy goes. And finally, where does it land? Does it land on land? Does it land on the ocean? And where on the ocean does it land, and how strong is it? So much of the earth is ocean. And that ocean controls so much of what we experience on land, especially considering close to 50% of our population lives within 100 miles of a coast. So the effect of the ocean, the temperatures in it, strongly determine how cities, growing areas, countries get affected by global temperatures. So we follow the energy from the sun through the clouds to the earth. We also do a lot of background. On average, I do research 50, 60 hours a week. I could probably build a small apartment with all the scientific journals I have read over the past, well, since I was 4, although I wasn't reading those too well back then. But we look at a variety of pieces of information. We check out old documents from Europe and Asia, monk records of their planting and harvesting. A lot of people view a monk as a holy person. I view them as a very intelligent, small agribusiness person because they kept intimate records of how things grew and when they grew and where they grew. We look at ice cores, we look at coral rings, we look at tree rings. We look at a variety of data that if we look far enough, we have at least 2,000 years of very, very solid data on how weather was. And it goes back to, some believe, as much as 10 to 15,000 years of good data that we compile to try to help figure out what's going to happen over the next 3 to 6 months. Now, right now what we are experiencing is Godzilla versus the volcano. And it seems a little bit of an extreme title, but the reason I say that is if you watch the news, if you watch the press, you've heard the old statement, if it bleeds, it leads. Well, it kind of follows the same thing with weather. If the weather is dramatic, it's going to take center page headlines. But you can't say an El Nino is hitting California. Slight higher rise in temperature in the Northeast. No, that's not going to grab people's attention. So I've been reading and I've studied, and we've had a Godzilla El Nino. We've had the Bruce Lee of El Ninos. We have had the worst El Nino in history. Now, when we talk about history, something to keep in mind. History, when it comes to most of those headlines that you see, goes back into the mid-1970s. That was when we started compiling satellite data. Most information that we find in news outlets on your average, whichever you read, doesn't take into account before the 1970s. We still haven't gone through a full oceanic cycle, which I'll explain what that means in a moment, compiling the data that we have from satellite imagery. But still, it's a Godzilla El Nino, and it's been a strong El Nino. And that El Nino mixed with the volcano, the Bartabunga volcano, once again, is helping to create what we are experiencing now. So along with volcanoes, along with watching the energy, we pay very close attention to the oceanic cycles. And we look at a variety of them. We look at MJOs, Madden-Julian oscillations. For the next couple minutes, I'm going to name drop a lot of really fancy sounding words that make me sound a lot more intelligent than I am at business parties. So keep them in your mind. You can drop them at some point. It'll impress your friends and neighbors. Madden-Julian oscillation, I like to call that the toilet flush of the Pacific. Seems a little odd, but if you're taking a shower and somebody flushes the toilet on you, you suddenly get a burst of freezing cold or searing hot water. Well, the MJO does the same thing. Whatever the Pacific Ocean is normally, MJOs create a very cold or very warm burst of water that goes quickly through the Pacific, lasting 4 to 6 weeks, and changes the outlook of that entire ocean. In 2014, we were actually experiencing El Nino conditions, but it never became an official El Nino, even though we had that sort of temperatures, because we'd get a cold MJO that would lower the temperatures just enough that it could not be officially declared an El Nino. I look at the IOD, Indian Ocean Dipole, and this has a major effect on Southern Asia, on Africa, and on Australia. And I've been doing a lot of research on southern hemispheric crops. So this has actually been something I've paid very close attention to. And if you ever go to a meteorological site in Australia, this is all that matters, is the IOD. It covers 90% of their web pages, is what the IOD is doing. I look at monsoons. In the U.S., we have our 4 seasons, and in a lot of countries, there are the 4 seasons, but so many countries, they have 2 seasons, the wet season, the dry season, the rainy season, the heat season. So the monsoons, where they land, how strong they are, how far inland they go, have a massive determination on what's going to happen in that region when it comes to their agriculture. El Niños and La Niñas. I'll get a lot more into those in a few minutes here, but that's another thing that we pay very close attention to, especially currently because we are in an El Niño. We look at the PDO, the Pacific Decadal Oscillation, which is a 50 to 70 year cycle. Goes 20 to 30 years cold, 20 to 30 years hot, so can be a little higher, a little lower sometimes. And right now the Pacific is normally cold, and it brings cold water to the western part of North America and warm water to the eastern part of Asia. The El Niño has changed that. The El Niño has made warm water along the east of Asia and warm water along the west of North America. And finally, we look at the AMO, the Atlantic Multidecadal Oscillation. This is a much longer cycle of 60 to 80 years. And it is currently in a hot cycle. We have hot water from the Atlantic on the eastern part of North America. So we have all these cycles all working together. They're like the gears of a clock. And if you know that your clock is working, you're going to know what time it's going to be in the future. We pay attention to the gears of our ocean to be able to determine what's going to happen in our climate and weather in the future. So these are the oceanic cycles that we're currently experiencing. We have the El Niño, we have the cold blob of water that's being created by the Bartabunga volcanic eruption. We have a neutral IOD. We have all these different oceanic occurrences right now, and these are all influencing what's happening in weather all around the world, but also what's happening right here in Indiana and surrounding areas. So I'm going to go into a touch more detail about the AMO and the PDO because it has such an influence not just on what's happening currently, but for the next 15 to 20 years. See, the AMO cycle is currently in that pink warm cycle that you see that dips into North America and then goes along the coast and then flips over to Europe. And we have 15 to 20 more years of that cycle occurring. And so because of that, it means that every year we are going to have warm water along the east coast of North America during the planting, growing, and harvesting season of agriculture. And what this means is it influences the type of weather that is normal for this condition, assuming it's not influenced by other factors. It means that we get more severe temperatures. It means that we get chances of strong snowstorms. It means that we get rainfall, but it's not a few inches over a couple weeks. It's a few inches over a few hours. And as you can see, the warm phase of the AMO, it increases the risk of heat waves, unfortunately, because the circulation of the jet streams and the circulation of the water temperatures and the precipitation that the oceans cause takes a completely different route than it did from the 1960s through the 1980s. And in fact, and I'll show this in a few minutes, the 1960s through the 80s, in fact into the early 1990s, was some of the most calm, benign weather that existed for North America. And that's a time that we created so many of our reservoir systems, our watering systems, our areas for planting and harvesting and growing crops. But now it's changed. As you can see with the AMO, it's changed, and now we have a higher risk of heat waves hitting into the Midwest, hitting up into the north, hitting along the East Coast. And in addition to that, we also have a higher risk of hurricanes. The hot water creates energy. As I said at the beginning, we follow the energy and where it goes. And so in this case, that hot water creates more energy for hurricanes to be stronger and last longer. This is why you're having hurricanes hit up in New York and New Jersey. This is why you have so many dipping into the Gulf Coast. There's more energy for those hurricanes. And when the hurricanes hit in New Jersey and New York, scientists were warning that the walls needed to help dampen the onslaught of water coming, needed to be raised and built. And the answer by politicians and other people, besides the fact that it was going to cost so much money, was, well, we haven't had a hurricane in 40 years here. And they hadn't, because of the way that the AMO cycle went. But now the AMO has changed. There's another 10 to 15 years, possibly even 20, of the higher risk of hurricanes flowing more easily along the eastern coast, going more easily into the Gulf of Mexico, and hitting land more often. And even if it doesn't hit land, you're still getting the remnants of it, the tropical storms that have been hitting so much more frequently. In addition to the AMO, we look at the PDO, the Pacific Decadal Oscillation. So from 1976 to 1998, we had cold water along the east of Asia, along the eastern coast of Asia, and warm water along the western coast of North America. And this created benign conditions. It created good rainfall. It's one of the reasons California became such a leading state in agriculture. Unfortunately, in 2005 to 2006, it changed. Just as people were starting to get used to the change of the AMO and what it did to weather patterns, the PDO changed, and it created a whole new onslaught of problems to deal with, especially along the west. Now we have cold water along the west of North America, and that creates drier conditions for anything east of the Rockies. It's one of the big influences, it's one of the big reasons that California has had such severe drought for so long. And there's other factors that have influences. There's the fact that their population has doubled in such a short time. There's the fact that their aquifers and reservoir systems have either gone under disrepair or have been stripped of their copper and other precious metals and parts. If a state isn't prepared for the change in climate, it forces them to be reactive. And when you have to be reactive, too many people can make too many mistakes far too easily. It's one of the things that we pride ourselves on. The information that I'm giving you today, that we give our clients in general, allows people to be proactive to weather instead of reactive, to plan ahead. So that once they know what the weather's going to do, they can plan for it and not have to worry about it as much and start focusing on the dozens of other little things in business and in planting and in agriculture that a person has to worry about on a daily basis. So, at my age, and I'm not very old yet, but I hear myself slipping into the back in the good old days speech. Now, for me, back in the good old days was when I was like 12 or 13 and everything was perfect back then, just ask me. But in a way, climate-wise, it kind of was. From the 70s through the 90s, this image on the top left is the normal precipitation that the United States got. And as you can see, it's relatively plentiful. We had a few areas that stayed dry, but for the most part, you had good rainfall going throughout most of the United States and even in Canada. And what this meant is that during the time that we created and founded so much of our agricultural outlook was during a time that we had very good and dependable precipitation. And in addition to that, this precipitation was several inches over several weeks, or a foot over several weeks. The image that you see on the top right is the new normal, and that's what we like to call it. The new normal when you don't have other oceanic or volcanic activity influencing what the Pacific and the Atlantic do to precipitation and weather. And unfortunately, it's a lot drier. Water storage and water usage becomes such a key impact and key importance when you no longer have the dependency of rainfall over the course of year-by-year basis. But instead, especially for areas in the south and parts of California for that matter, they have to depend on an El Nino, which is what you see there in the bottom right. El Ninos occur about every 3 to 7 years, so about a 5-year average, give or take. And what that means is that during that course of time, during that year or 2 years that the El Nino is influencing and hitting, it's going to create a lot of water. But if you paid at all attention to Texas during this past summer, they didn't get that water casually. They got flooded in spring, drought in summer, and flooded again near the end of summer. So without water conservation, without having a way to store that water, it meant that it was still a very difficult season for agriculture, and it can be in general for so many areas, because precipitation is not a dependable commodity that comes day by day, week by week, month by month. It comes fast and it comes strong, and then it goes away. And we find that also in our winter weather. Pardon me, I'm going to have a quick drink. So we've talked about the Pacific, we've talked about the Atlantic, elephant in the room, the El Nino, what we're currently experiencing. Now, as you can see, once again, going back to our conclusions, 90% of the different sources believe that the El Nino will last through winter, 85% that it'll last through spring. But by the end of spring, there's a pretty much general consensus, and we agree, that the El Nino will dissipate and eventually disappear. Now, the catch of the El Nino is this. You see this area, that dark red area, the 3.4. That area is very important for scientists because they pay attention to that one specific area, and they invented this back in the late 70s. That area has to be 1 degree higher than the average temperature 7 months in a row. And on that 7th month, they say, well, it's done it for 7 months. It is officially an El Nino. What this means, though, is that for farmers, for investors, for commodity brokers, for anybody who has to deal with weather, and most industries have to deal with climate and weather in some form or fashion, they've lived in an El Nino for 7 months. In 2014, actually in late 2013, we were experiencing oceanic temperatures that were creating El Nino conditions, and they would last 3, 4, even 5 months. And then 1 month it would be 0.9 degrees, 0.8 degrees. It would drop down, and the whole cycle has to start over. One of the things that we let our clients know about is the fact that we will officially declare as an El Nino at the same time the NOAA does, but we warn people about it ahead of time, because just because an El Nino hasn't been officially declared doesn't mean that people aren't living in El Nino conditions. And while we've had it throughout 2015, through most of 2014, we were also having conditions like an El Nino. It just was never officially reported. So that's one of the reasons that we seem to be experiencing this year situations somewhat similar to last year. Not exactly the same, but similar. So the El Nino weather for wintertime, we're looking at January, February, and March. And this is what we can look forward to, or what we should be experiencing with temperatures and precipitation. So as you can see, it's going to be stormy in Southern California. It's going to be warm and dry up in the north. And it's going to be wet in the south. And so for the south, it's going to be interesting because sometimes that wet will turn into snowstorms, something that's not terribly common in that region, but it has happened in the past. Additionally, if you look, you can see precipitation patterns. And we're looking at along the Corn Belt area, along the Great Lakes, and along the Northeast. We're looking at dry, or drought, no, not drought-like conditions, but drier conditions than the normal. In the south, we're looking at wetter conditions, more precipitation. Now, we're talking about winter. What this usually means is snow. And this doesn't mean that you won't get snowstorms, as we've had recently. Once again, we're in the situation now where the type of weather that we get is, when we get the precipitation for the month, it's not going to come over several days over the course of the month. It'll come 1, maybe 2 days. So we've talked about the oceans, the PDO, the AMO, the El Nino. Last but not least, volcanoes. Now this image is a little complicated. That's why I put it on your handouts if you want to look at it there. But here's the thing with volcanic eruptions. Volcanoes are the X factor. See, when I was in college, I had to take several courses on business math, statistics, and investment math. And it knocked me down, took my lunch money, and insulted my mom. I struggled heavily with those math courses, but I swore I would use it someday. And this is how I use it. If we were looking at weather and we were looking at a formula for it, volcanoes are the X. Volcanoes are what can change the overall outlook. The reason for this is that when volcanoes erupt, they create debris, what we call ash plumes. And if a volcano erupts 5 miles or higher, in the areas that they normally do, and I'm talking about northern hemisphere, so Iceland, Russia, other parts of Asia, for that matter, Alaska and northern Canada. If those volcanoes go 5 miles or higher, then they can influence the weather thousands of miles away. One volcanic eruption in Chevolutch, Russia, 2 weeks later will create snowfall and rainfall in the United States, in California, in Washington. It can sometimes dip down into New Mexico and even into Mexico. We had a client of a major gas company who had several oil rigs up in the Gulf Coast drilling. And it was late November, and there were 3 volcanic eruptions in Russia. None of them higher than 5 miles, 5 to 6 miles. But they combined, and at the beginning of December, that region had such severe snowstorms that they had to close down all of their oil rigs from drilling for almost an entire week. It caused major problems with their profits, and it actually meant that their gas prices went up on an average of about 10 to 20 cents a gallon. So volcanoes can mess with things. And the reason they do this is when they erupt, they get into the atmosphere and you get these tiny little particles of volcanic debris. And these aren't the type of particles like we see when we burn paper for ash. This is glass, obsidian. And as that plume goes through the atmosphere, it collects water droplets. And as it collects water, it eventually gets heavy enough that it rains out. When they erupt in Russia, oftentimes they will flow along the Pacific and they'll rain out in North America. If it's in Iceland, it'll go along Europe, it'll go along Asia, and if they're tall enough, and this is with any eruption, to make it into the stratosphere, which means 10 to 15 miles high, then what happens is we get a mirror of volcanic debris that's in the stratosphere. And as it acts like a mirror, it blocks out solar radiation, it blocks out sunlight. And it can stay in our stratosphere for 2 to 3 years, affecting weather over and over and over again. So we've had volcanic eruptions like this in 2011, 2012. And what it meant is for the time that it was blocking out that solar radiation, it created severe droughts in not only summer but also in winter until it eventually rained out. And it's one of the reasons that in 2014, late 2013 and 2014, you had people able to jump out of their windows in Boston and land in, 2 stories worth of snow. When it rains out that big, it's a massive storm. In addition, volcanic eruptions, they change the outlook for the different jet streams. They change it in Europe, they change it in North America. And so Russian volcanic eruptions, they make what would normally be a negative PNA, turn positive. And that means that we have a jet stream that goes up into the cold and then comes and swoops down into North America, into the United States, collecting all the cold and all the moisture that comes with it from up near the Arctic. And then it goes out. In addition, it sweeps through along the Atlantic, and it sweeps into Europe. And it blocks out a lot of moisture, and it creates dry conditions in Europe. That's one of the things that the Icelandic volcano did in 2015. Is it blocked out, it changed the jet streams, and it blocked out moisture in most of Asia. You got a little bit in most of Europe, and you got a little bit of rain in southern Europe, but Europe was in severe drought. It recorded some of the worst droughts in history. And their history actually goes longer than the 1970s, so that's a somewhat strong statement for them to make. So we look at past years. What we try to do is find years similar to what we are currently experiencing. And that's been a little difficult because right now we have the Icelandic volcano, we have a cold PDO, we have a warm AMO, and we have an El Nino. So the closest that we've been able to find to this are these 3 years. And there's one generality that we've found in all 3, and we're finding it also occurring now, is that the Northeast has always stayed cold. It's always stayed dry. Drought conditions during the summer, and dry and less precipitation in the winter, and warmer. Now the reason this is important for wintertime is because it affects energy prices, and it affects energy usage. See, the Northeast is kind of what determines the cost of energy, of propane, of natural gas for heating throughout the course of a year. And so therefore, if it's been warm in the Northeast, warmer than average, which it has been so far, what that means is that prices are going to, the items are going to be used less, and so prices are going to go up. And this can be problematic for areas such as the South, which is going to be colder, because they are going to have to use more, but the prices aren't based on that. They're based on mainly what's happening up in the Northeast. And so because of the prices going up, it's going to cost more for them. So this is what we're finding. That's one of the key components that we can find based on the previous years that we've had conditions similar to this. So this is our outlook, and we've made a pretty strong focus, and this is also in your handout, of the areas that you guys are interested in, Indiana and surrounding Great Lakes areas. And as you can see, once again, throughout most of wintertime, it's going to be warm until late winter. Now, that doesn't, when I say warm, this doesn't mean that, I can leave this area and go out in Bermuda shorts and a t-shirt. That's going to be cold. That's going to be very unpleasant. But it does mean that the average temperatures are going to be higher. It means that while we do get snowstorms, the snowstorms will be quick, fierce, and then go away. If you've looked at the weather, next week it's supposed to be in the 50s around this area. Near the end of winter, we're looking at it finally cooling down. And into winter is when we might start getting more snowstorms. What this means is it can create wetter conditions, but because it's snow, the amount of snow needed to create good soil moisture is much higher than it is if it's rainfall. What we find oftentimes is, unfortunately, with cold late winters, it creates dryness, and it creates harsher conditions for planting in the spring. Now, when you're looking at this early winter, mid and late, it's not quite December, January, February. It's December, give or take 2 weeks, January, give or take 2 weeks, and February, give or take 2 weeks. So it's going to be around that time frame, but we're not precise on that 30-day outlook. Now, another thing that we've found, food prices in general, when we have a change in the when we have a change in the PDO, we have seen every time that the PDO changes, goes from cold to hot, from hot to cold, prices jump. And the reason for this is when we have a major change in oceanic oscillations, it means that it takes a while for the agricultural community to get used to it. Now, this might change in the next 2, 3, 4 cycles, but considering how often, especially with the way that policies are made and plans are made, we don't have a 100-year outlook. We can't really afford to. We usually have, if we're lucky, a 2 to 5 year outlook. And so in this case, what you get is the PDO changes and prices fluctuate. They get high and drop and high and drop, but they never, once they finally calm down, they never drop back to where they were before they initially changed when the PDO changed. And so we're seeing that now. The PDO changed, went from warm to cold. It affected agricultural growth and productivity, and we had skyrocketing prices. And then they dropped significantly, and they rose, and they went minorly crazy. And in fact, in general, they jumped and have stayed high. But when they've dropped or when they've risen higher than normal, it's because of the influence of a El Nino or a La Nina. The reason for this is El Ninos offset the impact, especially right now, El Ninos can offset the impact of the PDO. It brings the rainfall when normally places haven't had it. It's the crossed fingers hope of so many people that it's going to create a normal precipitation pattern. Because for a lot of farmers, for a lot of agricultural people, for a lot of people in general, they look to their family, to their parents, to people who have been doing the business for a long time. But it was a completely different cycle then. It was a different AMO, it was a different PDO. Volcanoes and El Ninos and La Ninas had a completely different impact than they do today. And so when they turn to their parents, what should I do? How do I handle A, B, or C? The information that they're getting, while very sound, might be out of touch. Ironically enough, if they want to look towards the people that can give them the best advice, they need to look at their grandparents, because they're the ones who actually lived closer to a time that's similar to what's currently going on. So for those of you who had your father talk about, in my day I walked, really your grandfather, but the person who's saying in my day I walked uphill both ways in snow and it was always freezing. Well, when your father's saying that, they're crazy. But when it's your grandfather and you're the little kid or the young man walking uphill in snow both ways in New York or in that severe storm in Boston, well, I don't know what's wrong with Dad, but Grandpa sure knows what he's talking about. So when we have El Ninos, and this is the case for the next 10 to 15 years, expect a drop in the overall food prices, of commodity prices, because we have better agricultural conditions. When we have a La Nina, it makes the rough conditions, the drought-like conditions, it makes them even worse. Higher risks of drought, the drought spreads to more of the U.S., and you're going to have a rise in prices because overall yields are going to be much lower. So this is kind of what we're looking at when we have the cool Pacific and the warm Atlantic, so the new normal that we talked about, for agriculture, which you can see there in the table there on the bottom right, around the U.S. And there's that one green area that you can see there in the center, kind of around Iowa. That land is becoming very, very high value because that area, when the AMO is cold and the PDO is warm, gets good precipitation. When it's the other way around, it also gets good precipitation. But the only time that it gets rough precipitation is in El Nino, 1 to 2 years. And they have such a strong water use program, of piping water when it's needed, that they're still able to generate relatively good yields. So the image that you see on the right there is what we're looking at agriculturally wise when we have an El Nino and it makes the Pacific warm. Because that's what the El Nino does. It warmed the cold Pacific. So that volcanic eruption of Barda Bunga that we've been talking about, as you've experienced, it was one of the major factors of creating this cold snow, the storms that we got in Illinois and in Indiana. And once again, you'll see in headlines, and I'll show those in a minute, that we had record-breaking snowfall. But it's not quite how it would appear, and here's the reason why. When you get record-breaking snowfall, as long as it happens in one area, somewhere around where you are, then the press can say that, anywhere in the United States. So you had a record-breaking snowfall in Moline, Illinois. So therefore, Great Lakes area, the north, whatever region you want to cover, the press is going to say record-breaking. What they don't actually say is that in areas like Indiana, in areas like Illinois, it was one of the latest times that these regions had gotten snowstorms. Not quite record-breaking, but for some areas, it was the second or third latest time in the year that they finally got a snowstorm. But these are the different headlines that you see. These are the different records that were broken with that snowstorm. But because of the way Barda Bunga reacts, because of the way that we have with the El Nino, the AMO, and the PDO, despite these severe storms, and despite the fact that we have broken records, next week it's going to be in the 50s. We're not going to have much more snow for a little while. And when we do have snow again, when we do have that precipitation, it's once again going to come in record-breaking snowstorms. It's not going to come a couple inches over the course of several days. It's going to be a lot of inches over the course of a single day. So I had already showed something like this. I'm showing it again. For late winter, we're looking at our temperatures and our precipitation. And this is what we can experience. This is what we can expect for rainfall and temperatures in general for the north, south, for the United States. And as you can see in this area, we're looking at less precipitation, less snowfall, and warmer temperatures. Doesn't mean that you won't have really cold days. Just means that the average is going to be warmer and it's going to be drier. And so we transform that into spring and what we can expect in spring. Because of the potential of late winter snowfall, and because of the fact that winter is going to be cold near the end of February, cooler than normal, colder than average. One thing about cold is it brings dry. It makes things drier. That's one of the reasons California has had so much difficulties, because it has cold water against the Pacific, and cold water creates dry conditions. So what we're looking at, unfortunately, in this region is, as it cools, it'll eventually warm up, but we're not going to get the type of precipitation that we're used to. It's going to be a rougher planting season. It's going to be lower soil moisture. So we can anticipate a lower than average start out with crop, and a chance that a lot of crops are going to have to be planted later. Now the good news is that should the El Nino continue into spring and even into early summer, it does mean that you will get some rainfall in spring. So if the crops can be planted, they'll get the needed rainfall at least during the first half of their growing season. And it's not going to be significant rainfall to risk root drought. But it's going to be a difficult season this year in this area and the surrounding Great Lakes area when it comes to planting and the initial growing season. I talked recently about the fact that there's a good chance that a La Nina is going to follow soon. It can be a mixed blessing. If the La Nina follows in late summer, it means that it's going to actually provide a little bit more rainfall and kind of help boost those crops to get through the final stretch of their growing season. It does mean things will have to be harvested wet. So it means a higher use of propane to dry everything out. But it does also indicate a good chance that things will be able to last through the entire growing season. But if the La Nina starts sooner, if it starts in late spring or early summer, La Ninas bring more drought. So the timing of when the La Nina occurs is going to have a heavy determination on the type of crop yields that we can look forward to in the Great Lake areas in Indiana and surrounding areas. And finally, I've been paying very close attention to South America. And what quite possibly may have been one of the most boring yet interesting times in my life, I spent a year in South America, in Brazil, which was wonderful. But I spent a 2-day trip going through a major soy crop area and had very detailed information explained to me about what they do, how they plant, where they plant, what do they do with A, B, and C, but the entire thing was in Portuguese. I wasn't fluent in Portuguese at the time, so it involved a lot of charades, and charades on, what type of manure you use to have better crop yields is a very interesting game to play. But in this case, South America, as I said before, is our tiebreaker. We had lower than average yield crops in Asia and in Europe, heavily because of the El Nino, as well as because of the eruption of Bartabunga. We had better than average crop yields for North America, for the United States, once again because of the influence of the El Nino. El Ninos in the end are usually good things for South America. As you can see, we're looking at good rainfall in southern Brazil and in western Brazil. And you can see a lot of the growth, a lot of agriculture is created in that area. So thankfully, a lot of this rainfall came a little late into their planting and initial growing season. So they didn't have the risk of their roots getting flooded. So they had decent soil moisture, they were able to plant, and so far crop output looks like it's going to be good in most of the agricultural areas. The one area that's a little different that's going to struggle is Chile, an area where we get so much of our winter produce. You see, Chile is dry. They're just not getting that much rainfall. And when they do get rainfall, they're getting it in the north. They don't want rainfall in the north. They have mines in the north. They have mines that get flooded because of all the rainfall that they're getting in northern Chile. They're not getting it in central Chile, which is where most of their produce and crop output is. So the produce that we depend upon a lot that comes from Chile, that's going to be very low. And that's going to be made all the worse because of the low output of produce created in Florida and even more so in California. But other crops, the soys, the corns, the wheats, things like that, we're looking at good, solid precipitation likely to last through the remaining of winter. And what it means is that the overall global yield is going to be higher, which should drive food prices down a little bit, but it's a one-year trend. It's not going to be the normal because so much of this was affected by the El Nino, and that El Nino is likely to end by the end of spring. So I know that was a lot of information. Your handouts are there also to help. A lot of what I covered is there in your handouts. We're going to go through our conclusions one more time. Climate changes, it ebbs and flows. It's not linear. It doesn't always do the same thing. So if you can learn how to ride the climate, if you can learn how to ride it like you would ride a horse, you can get to your destination and your needs faster. 90% chance of the El Nino lasting through winter, 85% chance of it lasting into spring. Along with the El Nino, we have the Icelandic volcano Bartabunga that erupted and is influencing weather around the world. The combination is going to make for a dry and warmer winter in the north, a stormier, wetter south, and it's going to make for eastern corn belt to be drier for planting season. Rough for Asia and Europe, better than average for South America. Overall yield of crops is going to be higher than normal for this year. Not a lot, but a little bit higher. Last but not least, this is the general outlook of, it's a nice little condensed one page of what I went through. You're looking at the warm winter, Canada, Midwest, Mid-Atlantic, most of Europe. Cool winter in Russia, which is going to be good snow cover for their winter crops. Central Asia and northern China. You're looking at a wet summer, the dry summer in Australia and South Africa. You're looking at a wet summer in western and southern South America, specifically Brazil. So I'm James Garris with Browning Media. We do a Browning World Climate Bulletin. It's kind of similar to the handout that you have, except for it's 8 pages, done monthly, covers a variety of topics. We do all sorts of things. So if you're at all interested, it's also on your handout. There's our contact information. I thank you very much for your time and welcome any questions.